Hi there, welcome to my channel. This is Mrs. A and today you're going to learn about solving quadratic equations by extracting square roots. Before that, let's have a review first. I have here a set of perfect squares. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. These are the results if a number is multiplied to itself. Another way of asking this is, what is the square root of 9? And that is 3. What is the square root of 49? The answer is 7. What is the square root of 81? That is 9. And what is the square root of 16? 4. What is the square root of 64? And that is 8. Now, we're going to use this set of numbers in our examples. When we say solving quadratic equation, it means that we are finding for the solutions, which is the value of x. The standard form of quadratic equation is ax squared plus bx plus c is equal to 0. A, b, and c are real numbers. B and c can be 0, but not a, because if a is 0, it's no longer a quadratic equation. Now, what will be the equation look like when b is equal to 0? Which means we don't have middle term anymore. So, our equation will be ax squared plus c is equal to 0 or ax squared is equal to c. If this is the case, that b is equal to 0, we can now solve the quadratic equations. An alternative is by extracting square roots. Let's have an example. This is an example of quadratic equations wherein b is equal to 0, which means we don't have the middle term. X squared is equal to 9. 4x squared minus 16 is equal to 0. And also, look at number 5. X plus 4 quantity. X plus 4 squared is equal to 16. So it means something squared here on this part. So this one, x minus 1, or quantity x minus 1 squared is equal to 4. So again, this kind is still can be solved using extracting square roots. And number 7, 2x squared plus 2 is equal to 26. So we're going to learn how to solve for the value of x in this kind of equations. Okay, so let's start with. Now, solving quadratic equation by extracting square roots means using the square root property. And what is that square root property? If x squared is equal to c, then x is equal to positive and negative square root of c. So we are extracting the square root of both sides, and that would be the result is positive and negative c. Okay, let's have this one first. Before you're going to apply the square root property, the equation must be in the form x squared is equal to c or x squared is equal to k. Some use the symbol k. Now, look at this one. Let's have an example. We have x squared is equal to 9. By just looking at this equation, which means that we need to look for the value or values of x that will make it equal to 9. Okay, so like what should be the value of x that if you're going to square it, the result is 9? Think about it. What about 3? 3 times 3 is equal to 9. Yes. What about negative 3? Is negative 3 times negative 3 is equal to 9? Yes, because if you are multiplying the same sign, the product sign is always positive. So, it is also true for x is equal to negative 3. So, for this given equation, x squared is equal to 9, the value of x is equal to 3, and the value of x is equal to negative 3. So, we have two solutions here. Now, that is by just simply thinking about the value that we can substitute to x. Or applying now the property, the square root property, we have square root of x squared is equal to square root of 9, and that is now x is equal to the positive and negative square root of 3. What is the square root of 9? Is 3. So we have here, we're going to extract the square root here. It should be positive and negative. Okay, so let's have another one. We have here x squared minus 25 is equal to 0. Now, look at this. We have negative 25 on this side. We need to have this form in order to apply the square root property, which means we need to isolate x squared. So what are we going to do now to remove this number? We are going to add 25 both sides of the equations. So this would be equal to 0, and our x now, or x squared, is equal to 25. Now we can apply the square root property because this is already in this form. So x squared is equal to the square root of 25, and that is extracting the square root of both sides, right? And that would be what? The positive and negative here. Or that is equal to like this. And what is the value of x? Square root of 25 is 5. So positive and negative 5. So we can separate that. Our value first, value of x is equal to 5, and the second value of x is negative 5. Okay, next one. Look at the given here. 4x squared minus 16 is equal to 0. So we need to rearrange into the form x squared is equal to c. So we need to remove this one on this side and 4. So how are we going to do that? By applying the property of equality or properties of equality. So we have first, we need to remove negative 16. So by doing that, we can add 16 on both sides of the equation, and this is equal to 0. And what is left now is 4x squared is equal to 16. And then we need to divide both sides by 4. So this is 1. 16 divided by 4 is equal to 4. So x squared is equal to 4. Now we can apply this square root property. So extract the square root of both sides. We have square root of x squared is equal to positive and negative square root of 4. And what is square root of 4? 2. So we have x is equal to positive 2 and x is equal to negative 2. So again, in this case, we have two real solutions. Now, look at this, number 4. X squared is equal to 0. What is the square root of 0? We know that the square root of 0 is 0. There is no positive and negative in this case, which means we only have one real solution, and that is x is equal to 0. Okay, another one. X squared is equal to 8. Now we can apply the square root property because it's already in that form. X squared is equal to c. So what I'm going to do now is extract the square root of both sides, and that is square root of x squared is equal to positive and negative square root of 8. Now, is 8 a perfect square? No, 8 is not a perfect square, but you can reduce this, or you can simplify this radical form because it's not yet in simplest form. How are you going to simplify radical forms? You need to think of factors of 8 wherein 1 is a perfect square. So, what number can you think of factors of 8 wherein 1 is a perfect square? So, we have 4. So, if you're going to extract the square root of this, x is equal to positive and negative square root of 4 times 2, which is 8. And you know that 4 is a perfect square. So, we can extract the square root of 4. And once you extracted the square root of 4, you can put that outside the radical sign. So, that is square root of 4 is 2. So, therefore, we have x is equal to positive and negative 2 times square root of 2. So, square root of 2 is inside the radical form because there is no, or it's not a perfect square. So, but this one is in simplest form. So, our two solutions now, the first one is equal to 2 times the square root of 2, and the second one is equal to negative 2 times square root of 2. Okay? So that is your knowledge in simplifying radicals needed in here. Okay, so let's have another one. Look at this. We have something squared here is equal to 16, which means we can still apply the square root property. Seems like this is the x squared. Now, look at this. So we have extracting the square root of both sides. So x plus 4 quantity x squared. So extracting the square root means this symbols here and the square can be cancelled is equal to positive and negative square root of 16. Now, we have on the side, we have x plus 4 is equal to, what is the square root of 16? Positive and negative 4. If we're going to separate that, we have the first one is x plus 4 is equal to positive 4 and x plus 4 is equal to negative 4. And we are not done yet. We need to solve now for the value of x. Now, solving the value of x, we're just going to do this one. Solve the value of x of this because we separated already. How are we going to solve for the value of x? We have here 4 on that side. So we need to add negative 4 on both sides of the equation in the first equation here. Okay? Because 4 positive and negative 4 will make it equal to 0. But we also need to add on the other side, always on both sides of the equation. So what is left now here? This is equal to, this is 0. So we have x is equal to 0. 4 plus negative 4 is equal to 0. On the other equation, same thing. We need to add negative 4 on both sides of the equation because this is positive. So when you're going to eliminate a number, you need to add the same number but opposite in sign. So this is positive, therefore we need to add negative. Okay, and that should be both sides of the equation. And x now is equal to negative 8. Negative 4 plus negative 4 is negative 8. So again, we still have two values of x. Okay, sometimes quadratic equations have no real solutions, which means no real numbers. The solution is not a real number. But we can write the solution in terms of imaginary number. In math, imaginary number symbol is I, small letter I, which is equivalent to the square root of negative 1. Okay, let's see an example about like this. Look at this. X squared is equal to negative 16. You notice here, the value of c is less than 0, which means negative. And if we're going to extract the square root of both sides, we cannot get this answer, or we don't have answers for square root of a negative numbers. Okay, so here, instead of getting the square root of negative 16, because we don't have answer for that, we have extracting the square root, x squared is equal to, change that negative 16 into a factors of positive 16 times the quantity square root of negative 1. You notice positive 16 times negative 1 is still negative 16, right? So we have here square root of negative 1. So we can extract the square root of positive 16 only. And that is square root of positive 16 is 4, positive and negative 4. So x is equal to positive and negative 4 times negative 1. But that negative 1 is equivalent to I. So that I should be placed in here for I instead of writing times negative or times the square root of negative 1. So we have two values for x now. We have x is equal to, the first value is x is equal to 4i, and the second value of x is equal to negative 4i. Okay, and this kind of solutions are what we call two complex solutions. Okay, next. Or let's have another one like this. Look at this. X squared is equal to negative 9. So again, the value of c is less than 0, which means negative. And we can rewrite this as square root of x squared is equal to negative 9 can be written as quantity square root of positive 9 times square root of negative 1. That is negative 9. And now we can extract the square root of 9, which is 3. And instead of writing square root of negative 1, we can write I. So x is equal to positive and negative 3i. You can separate that as this one. Okay, so you're just going to look for an example that are similar to the given examples that I gave, and you can follow. You can rewatch the video if you want. And please don't forget to subscribe. Thank you for watching, and share my videos and more videos to come. And see you in the next one. Bye-bye.